All right, well, welcome everybody. Thank you for joining. It's great to be here. I'm pretty excited for the event. A bit about me, I'm Luis Mpe. I joined AWS in 2014. Since then, uh, we started working in Lumberyard, which has now morphed into what's O3D. And a large portion of the time I spent developing script canvas, among other things, but primarily script canvas. So today's workshop is going to be a bit on how to create stuff with script canvas using the new mechanism for spawning prefabs. In fact, let me switch my slide. Okay, so this is, if you're not familiar, this is script canvas. It's our visual scripting solution within O3D. It allows you to create behaviors and complex interactions of any kind of object or entity within O3D and to use many of the components that are provided for you. The goals for, sorry for shifting, the mouse is very sensitive. The goals for today's workshop is to learn how to dynamically spawn some prefabs, and we'll get to what prefabs are in a second. Learn through Canvas event-driven paradigms. It's unlike other visual scripting systems, in O3D, we rely a lot on event-based development, and we'll get into how we leverage those events to invoke different sets of functionality at different times. That'll be what we'll cover in learning about script events, and then we'll learn how to use variables and maps and other containers within the script canvas editor. For the workshop, I am using the development branch of O3D. You can get it on GitHub. And I have a project that I've created with a lot of the content you'll see today. You can get it from that repo. And you should be able to look at all the examples that we're going to go through and be able to use them as you follow along. All right, so what will we learn and practice? This is a short video. In fact, let me just switch to the live view. Oh, does it work? Could I get could I switch to another view? Could I switch the presentation? Oh, here we go. Never mind, got it. So this is what we're going to be looking at. It's a small procedural generation of a building, and it's randomized. Every time we run it, you get a different result. And we're going to go through all the steps on how we achieve this effect. Let me go back to this. Okay. No. Okay. So a little bit about the content that I use in this demo. It was all created in Blender. It fits the standard Blender unit, but you have to be careful. I noticed that in order for it to fit properly in O3D, I had to set the unit scale in Blender to 0.5. That way it matched perfectly. When I moved elements in script canvas by 1 unit, it moved just like it would have moved in Blender. So it's an important detail. And then I created very simple constructs, some walls, window, a door, a roof. But you can imagine that you can create any sort of content and then use the same concepts to spawn environments procedurally. You can spawn your game as you're playing, or you can spawn elements that the player will interact with throughout the game. So the first step was to, after creating the models in Blender and exporting them as an FBX, is to make a prefab of each of those models. And I can show you quickly how we can do that. So let's say I have my wall. I'm going to find my wall FBX. If I drag that into the scene, oops, I completely lost it. Oh, sorry, my bad. There we go. So that's a wall. This right now is just an entity that was created because I dragged the FBX into the scene. We can go and right-click and say create prefab. And this is going to allow us to create an actual file, which we can then use in other places. So now if I look in our asset browser for prefabs, we should have a wall FBX prefab here. The wall, that's the one that we're going to use later. This one, this is the one that we just created, and then you can drag that in and use it throughout the scene. And this is important because we're going to use this to spawn from script canvas. We spawn spawnables, which are prefabs, rather than spawning directly from the FBX. There's way more detail about what prefabs are and what they can do, but those are covered in other workshops and other sessions. But they are very powerful constructs within O3D that you can customize and create complex hierarchies of objects with different transforms. But for this workshop, we're going to keep it very simple, as you saw. So going back here, I don't know how to make it not go back to the beginning, but all right. So how do we spawn a prefab? This is the first step in as we dive into script canvas. So I'm going to go back into script canvas. We're going to open it, tools, script canvas. And you can just create a new script, and we will reference our script. So as you see here, we have an on-graph start. This just signals that the script's about to execute. We're going to run that graph. The first thing we will do is create a spawn ticket. This is useful to manage the lifetime of our prefabs as they're spawned. So we can keep the ticket around. If ever we need to despawn or get rid of that object that we created, we can use this ticket to do so. And then we call spawn, which optionally has some parameters like transformation, rotation, scale. And for now, we're just going to keep them blank. And the only other detail is here in the variable manager. So let me go and show you within script canvas how we're going to do it. I will create a variable called prefab, spawnable, of spawnable type. And this is what allows me to reference the prefab asset that we created earlier. So here I can click the find asset, and we created our wall FBX prefab. So we're going to reference it, and now we have a variable that holds this reference. And if we go back to the graph and we do on graph start, we'll do create spawn ticket as before. One thing we can do now, to create a spawn ticket, we require a prefab. And in order to do that easily, oh, I'm sorry, it's not showing my bad. There you go. Okay, so backtracking a bit, I went to create variable. I looked for a spawnable script asset reference, and this creates a variable that allows me to find the asset that we previously created. And with this asset, I will be able to now pass that variable into the create spawn ticket node, and it'll be referenced, and we will be able to spawn. So I can just drag the variable from the variable manager onto the reference slot that requires it, or you could also drag it and do get and then connect it manually. Either way is fine, but using the variable reference method creates more concise graphs, so it's a lot easier to manage and understand what's going on. And once we've created the spawn ticket, now we can spawn our wall. So we're going to call the spawn function. And the spawn function automatically connected to a spawn ticket, so it identified that there was a type that correlates to the other node, so it did the connection for you. You could also store the spawn ticket as a variable, which would allow you to reuse it later if you want to despawn. So to do that, we will come here and search for ticket, entity spawn ticket. I can just call it for now the ticket. And like before, we could disconnect here and we could just drop it in. And now when this node is called, when create spawn ticket is called, it's going to assign that value onto that variable, which we can then reference in multiple places. So I can just drag it into the new node. So it just makes it very easy to create your behaviors, makes it very simple to just craft what you want to achieve. And now with this graph done, we can save it. We're going to call it for now just test01, something simple. Now we're going to create, in fact, I'm going to temporarily, oh, it's okay. We'll create a new entity and we'll call it just the wall. In order to use a script canvas graph, we want to give an entity a script canvas component. So I'm going to go to add component, so script canvas, and now we want to reference that graph that we just created, which I called test01 for easy access. And now we have it assigned, we have it set up. So if I run this, we should see that wall show up, but we'll also see that the old building generator. So I'm going to temporarily delete it, just so it doesn't interfere. And there's our wall. So I pressed Control G. Control G transitions from editing to game mode. And now we are within what's the game. And you can see that we spawned a wall. So it's pretty simple so far. I'm going to undo to bring back my other entity. It didn't work. So I'll just reference the previous script that we'll work our way towards it. So now if I run it, we can see the previous behavior. Okay. All right, so that's spawning a simple prefab. That's the least, the minimal code, the minimal graph in script canvas you need to spawn something, which, as you can see, it's just 3 nodes, pretty straightforward. But you can complicate it a bit more if you start adding translations or rotations and other parameters, which we're going to do. So that's, let me go back to that view. Okay, so this is what we achieved. We've spawned a prefab so far. So how about a sequence of prefabs, right? How can we spawn multiple walls? As you saw in the demo, we're building a whole structure, and just spawning one wall doesn't quite do that. So we're going to go through this exercise. It's very similar. The only things that we will add is a position variable that holds a vector 3, which will increment every time as we're placing, and a repeater node that just calls multiple times the same behavior. So if we go back here, we can move our onGraph start, and we can just disconnect it and do a repeater node. So we go there, repeater. Now the repeater node allows us to configure it in different ways. We can set ticks, milliseconds, seconds. It depends on what you're trying to achieve. In order to create the content today, I did find that you want some amount of time between repetitions, because it takes some amount of time for a spawnable to actually spawn. So you want to give it some interval. I think 2 or 3 frames is enough, but let's go for 4 for safety, and we'll do, I don't know, 5 repetitions for now. And I'm hard-coding the values right now just for show, but we could actually use variables that, for example, a number variable here, and we'll call this the iterations, and then we can use that instead of just hard-coding the value. And even more importantly, what we can do with that number in the variable, we can go and say that the initial value we want it to come from the component. This means that when you configure the component in the editor here in this view on the entity, we will see, let me bring this back to the other script that we're working on. We'll see that the variables will start showing up here. So we'll do that when I save. Now we have iterations here, so now we can easily configure or customize each use case of the script. So now that we have that, we will connect it to the action. This means every time the repeater node is invoked, action gets signaled, and then we're going to create. And finally, I did mention that we need another variable for the position, so this will be a vector 3. It's a position in 3D space, and we will use it here as our local translation. And finally, if we reference back, when we complete our spawning, excuse me, we will adjust that position. So we'll do it here. We'll do an add node, and we will drag our position into, and we're going to just add one on the y-axis. And then we will, this is important, I always forget this part, we need to assign the position back. So when we add to a position on the left side of the node, we want to make sure that we are assigning it to the result. So this makes sure that your position will be updated. So we can save that graph now. Now when we run this, in theory, should have had a sequence of walls, but something did not work. Let me check what's going on. I'll just set that back to how I had it. Quick, oh, I know why. Iteration is set to 0. That's my bad. So we can go here, which is a good point that I will talk about in a moment. So now I've set iterations on the wall to 5, and then we run it. Now we have a longer wall than we did before. And it's just by spawning 5 walls next to each other. Like I mentioned in Blender, it's a 1-to-1 unit. So we're just moving by 1 unit and the walls align perfectly. The thing that I forgot to do was assign a proper default value to the iterations. So if we set a default value, let's say 3, at a minimum it'll be 3. However, we can override that by just setting it here to some other value. So we go for 8. Now we have 8. So that's one way that we're using to spawn a sequence. And then we can start making this more complex, right? We can start making parallel walls, and we'll get to that. Let's go back to the. Okay, so we spawned the sequence. So next up, I want to show you how we can now use script events to start creating more complex elements. So in order to create a script event, we go, let's minimize script canvas for a moment. In Tools, there's the Asset Editor, File, New, Script Event. Let me make this a bit bigger. And a script event is basically a little bit of data that we're going to create that allows us to say, I want to pass some amount of information from one point in a graph to some other point in a graph. You can also use it to pass data from script canvas to Lua, or from Lua to script canvas, or from completely disconnected script canvas graphs. So you can send information from one entity to another. It's very useful if you're doing collision detection or tracking score or any type of thing like that. So if we go back to here, we will create a script event. We will address it by string. The address of a script event is just an identifier to connect the two places. So we can address by entity ID and say, okay, I want you to send this event to that entity ID, and then that entity will be able to handle it. For simplicity, in this case, I'm using a string because what we're going to achieve is, if you can see in this slide, we'll have a set of nodes that represent these script events. And by using a string, we can say, go from point A to point B and just execute this code in between. So going back, the script event that we create, address by string, it's going to have the number of iterations, a direction, a rotation, the next event, so we can chain these events to create a different set of walls. And it's also going to have the prefab that we wish to spawn. This is a utility, a useful thing to make sure that we are always like carrying over the prefab that we're spawning to the next part of the sequence, which also allows us to randomize at some point which elements of the wall we are using, which is how we achieve that effect that, oh, I don't have that yet, but the effect of having windows or doorways. So back to that. All right, so we create the script event. I already have it created, so I'm just going to open it, but we're going to dissect it a little bit. So loop events, I'm going to expand it all. So this has the same structure that we saw on the slide. The script event is called loop events. Address type is string, like we talked about. Then we have the first event, it's called start. This is used to signal that we're going to start creating a sequence of spawnables. Iterations, how many, the duration that we're going to that we're going to configure the repeater node. Then that's of type number. All the parameters that you pass through a script event can be typed to different elements, different types. The direction, this just, we use it to say, okay, we're gonna spawn along the x-axis, along the y-axis, back to the x-axis. And then we can also leverage that for like height. Rotation, this is useful when we are moving from the y-axis to the x-axis. We're going to rotate by 90 degrees. And finally, the next event. So I'll show you how this is being used. Let's go back to script canvas. Let me close the slides. Okay, so first let me show you what it looks like when we create a script event. Here on the node palette, we will get a field that says script events, and any event that you create will just show up here automatically. And we will see the two events that we created, next and start. And so dragging these onto the graph gives you the option. Do you want to send the event or do you want to receive it? So initially, let's say you want to send it. You will get a node that has basically the configuration that you gave your node when you set it up in the asset editor. And whenever you call from, let's say, on graph start or from some other part of your logic, it's going to invoke it. Source, this is the address that we talked about, and it's going to be useful mostly in the case of receiving an event. We want to be able to say, let's say that we call start and our next event will be next. Then I can handle that here and say, okay, whenever I get an event of the name next, we're going to handle this case. And it's going to pass along all the same information. So we basically create this decoupled set of data passing that we can leverage for our wall spawning here. So let me find the start and we'll start going through it a little bit. Here. So this is how the whole building of the structure is laid out. On graph start, we're going to start by populating the y-axis. So I call start and I set it up to, it's going to send a wall event. Iterations, I'm using a variable called width so that I can have a different width and depth on the wall, on the structure. And we'll see it in action in a moment. The direction is going to be along the y-axis. No rotation is needed for this wall. And then we're going to chain the next event will be also wall. So we'll just execute this several times and we'll just pass in the wall prefab. So when this gets called, it's going to invoke this event and something needs to handle it. So if we go, that's not here, this is our wall event. And this is going to get immediately handled and we will get all the data that we just passed in through the start. And this will be familiar. We call the repeater node. So we pass in how many repetitions we want. I just have a small interval just to make sure that we give enough time to spawn the spawnable, the prefab. And then we will, once this repeater is complete, we go to the next event. So the difference now is that in this script that I have here, I'm actually doing a bit more advanced behaviors because I do want to have the randomization that I talked about. And to achieve that, I used a container. Let me come back to that and let's just look at a simpler example because otherwise it's a bit complex. I don't know where my graphs are. Okay, we'll just do it we'll just do it here. So we'll move this out of the way briefly. Pretend you didn't see the for each container for now. And this is connected here. So as before, every action will create a spawn ticket, and that spawn ticket is going to use that prefab that we passed in, the prefab that we wish to spawn. We'll create a ticket, and we'll call spawn, passing along that position and that rotation, and we'll keep scale to 1 for simplicity, and updating our position just the same way we did before. And that's pretty much it for each of these sections. And then once the repeater is complete, I'm using the next event. And this is the one we saw from the script event. So I'm just sending it. This allows me to then chain this sequence and say, okay, we've completed spawning one segment of the wall. We're going to move to the next one. And if we see here, we have one of these events for each of those. Let me show you. So next event is a variable reference that we passed. Let me go back to where's my start. And we said that the next event is going to be called wall. So then when we handle wall, we're going to be handling the x-axis. And I do a little bit of adjustment on the position just to make sure that because we are moving the wall along, the pivot's going to be on the center, so we need to adjust it a little by that half offset, and then we will rotate it. So now we are passing a rotation of 90 degrees. And we call start again. So this resets the sequence, starts all over again, and we begin another sequence. And this one now has the next event is wall 2. So as you can see, we're just reusing the same kind of logic to just reuse a lot of the code without having to have a very complex graph that has every single spawning for every single side of the wall, a lot of repetition. We've reduced it by a significant amount. So we go to wall 2, same as before. We do a little bit of offsetting to make sure that the wall starts spawning at the right place. And then we call the start sequence. And the next event's wall 3. And then on wall 3, it's the minus x-axis, same situation. But now we're going to move to a new event called new floor. And this is because we've completed the whole structure, the whole first floor of the structure. So we can actually start moving up a bit. So if we go to the loop event for new floor, next, I am using, again, a small delay just to make sure that we've completed spawning everything in the structure. I have a variable called floor. It just keeps track of which floor we're at, and we'll just increment it by 1. Again, just make sure to assign it to the result. And then here we do a bit of logic. We're checking how we achieve the max number of floors that we are allowed. If not, so if false, then we're going to create a new vector from the value 0, 0 and the number of the floor. So it'll just be on the Z axis, and we'll assign that to the position. So now we have a new vector at the beginning of our sequence, but just offset by 1. And then we pretty much go back and do the wall again. So now we do another wall, except that our position has now been incremented by 1 on the Z axis. So now you do that. So now we can go up every single floor. And then finally, once we've completed all the walls and all the floors, we can go to the next event, which I call roof, which is what's going to, actually the roof was a more complex part of this setup. We go and handle the event for roof, in which we can, it's a bit complex because now I have to track positions pretty much in the same way as we did for the sequence, but they are next to each other. And so filling that out was a bit more challenging. So I have 2 variables, y and x, and I just prime them to the beginning with a little offset so we make sure that we are starting the spawning where we expect it to be. Again, we create a vector 3 from those values, so from x, y, and the floor we're at. So the last floor we spawn, that's where we'll begin. we assign to our new position, and now this is a bit familiar again. We do a repeater, and for the width of the structure, we're going to go, and as long as the width is less than the y-axis less than the width, we'll create a spawn ticket for the roof, and we'll spawn it at that position and rotation. Rotation is a bit irrelevant in this case because it's not directional. There's no directional element on the roof, but there could be, and you could choose to randomly spawn if you had some interesting roof, or if it needed to. Let's say you have a roof that's slanted, you might want to rotate it accordingly to the edges. So this is where it can get more complicated as you work on things.
Luis,
Finally,
I'm sorry
yes.
for the interruption, but
No
we have a question from the audience, the virtual audience, and they say the Clone This Project GitHub link is not working. Do you have an updated link for them to follow?
I don't at the moment. It
Okay.
should work, but I can follow up, and I can, once we're finished, I can check what's going on with it.
Perfect. Thank you.
Yeah. Feel free to reach out to me on Discord as well if needed, and I can help guide you through it. Okay, so finally, we update our y value by 1, and this is just kind of filling in like painting almost, and we update our position. And so this is following the same kind of setup as we did for just creating a structure, and just as a reminder, this is what it looks like. Quick note, I mentioned earlier that you can expose parameters of the graph to the component. So for example, if we wanted to change our width and say maybe 5 and 2, and maximum of floors 7, now we will have a different structure than we did before. I cannot move for some reason. Oh, there we go. So see, now it's a completely different configuration, and there's the roof. And yeah, you can change these parameters. So now I do want to go back and talk a bit about how we achieved the randomization of the wall. And as you can see, those are different elements. Like we have the window, like this shape of window. This is supposed to be a doorway, and ideally you would constrain it to only spawn doorways on the bottom level. But I didn't want to complicate the graph too much, so I kept it simple. But for sure, you can limit where you want to spawn different prefabs. So if we go back there, let me navigate back to that spot. Okay, so how do we achieve a bit of randomization? So here we have a container of a number. Let me close the minimap. A number and a spawnable. So you can see, I basically use the key as a random weight for which prefab we will use. So I have a bit of logic that will compute a random number from 0 to 1, and if the number is less than the one that as we iterate through this container of prefabs, we check against this number, the key, so 0.2, 0.3, 0.4. So if it's less than that, we're going to use it. It's a very simple way of doing some kind of random behaviors. There's better ways to distribute this, but just to show how you can quickly have different results. So every time we iterate through this container, we get the number, we compare if it's less than some random number we just created, and if it's true, then we set the prefab we wish to spawn to the value of this map through this spot here. Here. And now we've replaced what we're going to spawn, and that's why we were sending that spawnable through our events here, prefab to spawn, so we can swap it as we're building the structure. So this is a very, very simple way to do it. There's a lot better ways, but let me show you about the map. So if you want to create a map like that, you go and type map, and this brings this other UI, and we're going to say random map. Now you can specify the types, so you can be different keys. In my case, in the case of this example, I use a number as a key. Just a very simple way to do weighted randomization. And then you can choose, oops, my bad, different set of types. So for this example, I use the spawnable script asset ref, and now this random map will be empty, but we can start adding elements to it through here. I may have just crashed my build. Okay, so in the meantime, while that thinks, let's go back to the slides. Okay, so we saw how script events can be used to decouple the execution and reuse some of the execution. We talked about adding the variables. We created our walls. This is showing the sequence that I talked about. I showed it live in the demo, but in the presentation you can see how we are, like, every axis is being generated one at a time, and how it's doing it through the use of the script events, and then how we can use, this explains the prefab to spawn. So, and this is what I just talked about, the random prefabs. So you just jumped ahead all those slides, but this shows how that worked. And then finally the floors, how we increment the Z value to achieve the floors, finally the roof. So we went into detail into all of them. If anyone wants me to go back to any of them, let me know. And yeah, so this workshop, this demo is pretty straightforward. It can be improved in many ways. Like I mentioned, doorways should probably only spawn on the first level of the structure. Even then, you might want to only have one doorway. Windows, I had some windows that had an awning on them. I don't know if you noticed in the demo, but I can show you. Oh, right, the editor crashed. But the point was, I don't think they're here, are they? No, they don't show. But some of those have a certain orientation based on where they are on the structure, so they need to be rotated according to the outward facing wall, which is not being done right now, just in the interest of not over complexifying the graph. For sure, all the materials, all the colors can be configured through script canvas as well. We can override materials, we can set parameters on them. We could configure their color or completely change the texture. There's as many ways to do it. We could add more random elements through greebles, which if you're familiar with like Hollywood and filmmaking, greebles are just elements that effect artists add to like spaceships to make them look more interesting, just break up the repetitive patterns on them. And you can use these techniques to build, not just for buildings, you can create vehicles, roads, voxel-based things, create random dungeons. There's any number of things you can do. One interesting effect that you could do is create tunnels as you're moving. Let's say you're in like a spaceship game, you're moving through a tunnel, you're generating the content as you go. So a lot of opportunity there to do cool stuff. And yeah, finally, this is an invitation to get involved. Script Canvas could use a lot of improvements from the community. It'd be great to see improving the way functions work with latent operations. Because I imagine that's a question that might be in people's minds is, why didn't you just use functions? In the process of doing this workshop, I found that spawning in functions actually created some issues that need to be improved. Same situation with looping structures, such as a repeater. It didn't behave really well when there was latency involved. That's why I had to add some frames to kind of wait for things to spawn. So we need to improve that on the scripting side. We have a script event editor that we moved into the script canvas editor itself. It's in preview, but it needs some improvements to make it a final product. So if anyone's interested in joining that project, that'd be great. Could definitely use a for loop node that simply you say run 5 times and it just runs 5 times, but not like the repeater. More that we get to tell it when to repeat, so we can control and be more event driven. Wait for something to spawn and then iterate on the next one. And I found that sorting containers could be really useful. When I used the map for doing some weight-based calculations, it was limited to the order in which I added the entries. I had to add them in orders for that algorithm to work. If I could just sort it, then the entry of those keys wouldn't matter, because we just sort the container and then it's always consistent. If you want to get involved, you can just find Good First Issues in GitHub, and I included a code there that you can scan, or just jump to that link where you can search with those parameters for Good First Issues, and that way you can start contributing and making scriptcast better. And that's what I got. Anyone have any questions? No? You, sir, in the audience. No? No questions? Sorry to put you on spot.
Hi. So yeah, you pretty much showed a procedural generation capability for the editor. Like, could this be extended for more game-related purposes? Like, could you see this expanding for actually showing, like, creating levels that are playable?
Yes, that was the motivation behind this workshop, to show how we can start that process, how you can start creating content or assembling content in real time. In many games, you might want to produce things based on what the player is doing. So this is a way to do that. Through prefabs, we can get a good part of the way there. Once you spawn the prefab, you can customize it at runtime. So based on whatever is happening in your game, you could change its color, change its position, change any attribute in it. Even its behavior, you can swap out what it's doing. Its whole scriptcast graph could switch to something else. So you could completely customize behaviors. It's pretty versatile like that.
Thank you.
Thanks. Great question. I forgot to repeat that question, but I guess it worked. Anything else? No? Awesome. Well, thank you, everybody. Really appreciate it. And I hope you have a great rest of the conference. I look forward to seeing some of your talks.
Starting with on-graph start node versus on-edity, activated versus on-tick, etc.
Okay. It depends. So on graph start is just a simplicity. It's like a shortcut node for on entity activated. They behave the same way. So it just makes it a bit smaller, easier to see. On tick is when you want to have something that happens every frame for some number of frames. So you can, I don't have the editor running. So that's something you want to do if you need to control something for some duration of time. You don't want your graphs to execute more than they should, because it's going to affect performance. You can imagine if you have 10,000 entities and they all do something on tick, now you're incurring a lot of performance cost. And this is why we do a lot of event-based programming, so that you can control the duration and the life cycle of your behaviors. So on graph start and on entity activated, it's the same thing, with the difference that on entity activated would allow you to listen for a different entity. So you can wait for some other part of your prefab to be ready before you do something. On graph start is only for the entity that the script canvas graph is actually on. And yeah, non-tick is probably not something you want to use in place of on graph start or on entity activated. It's something you want to control more for performance.
Thank you. Okay, that seems to be all the questions from the virtual platform. Thank you.
Great, thanks. Thanks, everybody.